Great. Thank you for everyone joining on today's webinar. I think we're just going to give things one more minute just to allow a few others to log in. But after that minute's up, I will join back with everyone and we can get things started. So thanks very much, and just hold on a little bit longer. Great. Well, thank you everyone for joining today. This is now our 7th webinar for the Alliance. We have some exciting changes and updates for today. One major change to note, both in our Alliance logo and in today's webinar focus, is that the North American Alliance is now the Americas Alliance. It really represents our commitment to inclusivity, our promoting a global awareness and understanding of smart water opportunities. So from here on out, we'll be thinking about challenges, issues, and solutions that span both North and Latin America. Some of the issues that we'll talk about will look quite similar throughout, but undoubtedly we'll discuss and address nuances in both regions that will advance our thoughts and knowledge leadership. Just some quick housekeeping items throughout the presentations. If the audience, if members there have questions, do put those into the chat box. What we're going to do is collect those and address them at the end. I'll help moderate that. And the webinar is going to be available later via the archive, and you can access through the Alliance webpage. So if you do want to pass this on to others that weren't able to attend today's session, that'll be available. So with this, we've got a great lineup of SWAN speakers from Latin America to discuss their utility challenges and opportunities for growth through smart water solutions. To quickly introduce ourselves, my name is Seth Cutler. I help lead the events team here at the Alliance. The more visible results of the events team are the webinars like here today, but also annual workshops we host for members and industry stakeholders. So with us in the panel today, we've got 4 speakers from 3 utilities in Latin America. We have Wagner Carvalho, Senior Project Manager at Aegea in Brazil. We have Sebastian Otero, a Network Manager from Esbio in Chile. And from Esval, also in Chile, we have Francisco Iturriaga and Renato Vanzulli. Our guest speakers have prepared some really exciting content for today, and we don't want to keep you waiting too soon, but if you can, or too long, but if you can spare me a few minutes, I just want to take through some additional points and talk a little bit about Alliance activity over the past few months. For those of us joining for the first time, the Americas Alliance, the aim is to accelerate smart water and wastewater development through collective global expertise. Those of us here recognize the strong value proposition and development of smart water initiatives in the region, and indeed we're becoming leaders for the rest of the globe. The Alliance offers interactive engagements such as these webinars and workshops, while also being a leading source of smart water information and insight. These opportunities are key events to collaborate and engage with fellow utilities, vendors, and stakeholders. Further, while in the past we've delivered freely available content, we're now focusing on member growth and access and really promoting interactivity and engagement between members. You can see here a snapshot of Alliance members and partners. The organizations span water utilities of different sizes, industry partners that deliver an array of solutions, and research and industry organizations that help to mediate, moderate, and push the industry forward. So we look forward to seeing this visual grow as further organizations become members. And certainly if there are any questions about membership or about the Alliance, do reach out to us and we can help you get that information. Here's a quick view of the Alliance leaders and also the groups they manage. Gary Wong is the Alliance chairman. He leads and facilitates the Alliance's growth and helps to create and further the vision. Outreach and managing the Alliance's messaging is led by Christina Foster. Events led by myself, I outlined just a minute ago. Ting Lu develops partnerships between the Alliance and key industry partners such as WEF and AWA. Research and furthering Alliance knowledge is led by Eric Bindler. And then also Emma Weisbord is growing our partnership through the inclusion of young professionals entering the smart water landscape. Last, before we go to today's webinar, I want to just bring some key takeaways from the recent annual conference SWAN held last month in Miami. This was the first time the forum met in North America. It was a great opportunity for Americas-based individuals to engage locally. 340 individuals from 20 countries attended. They engaged in 13 innovative panels dealing with subjects spanning water and wastewater development areas. Attendees benefited from interactive roundtables, a gala dinner, and networking opportunities throughout the 2 days. The day previous also hosted excellent kickoff events through a digital twin H2O workshop, a swim workshop, and a smart water hackathon. To highlight some further firsts, I did mention this was the first conference in North America, as well as being kind of the shift more towards the Americas Alliance overall for the group. But additionally, we had the first Alliance Breakfast Network meeting and networking session. So it was really a great time for both North and Latin America to get together, share insights, and exchange contact details for further growth. The conference also featured Hamilton Amadeo, the CEO of Aegea, as a keynote speaker. So we really enjoyed bringing everyone together, sharing new insights, and looking into different parts of the smart water landscape globally. Now, what I want to do is really get into our presentations for the day. So I'm happy to pass the presentation on to Sebastian Otero, who will tell us more about Esbio's activities and moving towards integral network management. Sebastian, I'm happy to pass it over to you now.
Thank you very much. Hello, everybody. Today I will be speaking about what we have been doing in the last few years at Essbio and how we started our smart water journey. First of all, we are a private company owned by the Ontario Teachers Pension Plan from Canada. We are the second largest water utility in Chile and serve around 20% of the population. That's about 3.5 million people. We operate in an area that is similar to the size of England, and our main challenge is that we are spread in over 120 districts, from small towns to big cities. Our drinking water network is almost 10,000 kilometers long. In the year 2010, we had a very large earthquake that was 8.8 degrees, and it severely damaged our infrastructure, and we experienced a sharp rise in the non-revenue water levels. So we started a loss reduction plan, which was mainly based on leak detection. At the beginning, it worked fine. We were able to reduce 4 points in the non-revenue water level, but after 5 years of our actions to reduce losses became less effective. And there we had a problem. We were not reaching our results. The results were not sustainable. And additionally, we had the worst continuity index in the Chilean water industry. And we had to pay out over $2 million in fines. That is why in year 2015, after making some research and benchmark with other utilities, we decided to move on towards an integral network management model and start our smart water journey, following the best practices and recommendations, such as, for example, the 5-layer model from SWAN. This means we had to make a change in our operational and asset management model, and therefore we defined 5 action lines, which I will now describe. That's operation, monitoring, commercial, maintenance, and risk. First of all, we had to start making changes in our operation, improving our hydraulic modeling, which is a key factor to succeed since it's the base support for every decision. Therefore, we made a plan to upgrade and update our models and train our engineering team that is in charge of the hydraulic models. On field, we started optimizing our pressure management by upgrading and optimizing the existing pressure regulation valves, installing new PRVs, and also installing smart pressure control systems in the critical PRVs. One successful case or example is the city of Linares, which has 90,000 inhabitants. Here we installed a 600 millimeter PRV with smart control and reduced by 60% the network breaks, as you can see on the graphic on the right side. Our challenge is to have our complete network operating under 4 bar. The next thing is monitoring. The best practices tell us that without monitoring, the results cannot be maintained. For several years, we made leak detection campaigns, but after a few years, the losses got back to the same levels as before. That is why we started monitoring key performance variables such as pressure and flow. We have installed almost 700 online pressure monitoring sensors, but here we have had a lot of communication problems since the loggers are located in underground pits. The pressure data also has helped us to improve the hydraulic models. And with a large number of sensors and data comes another challenge: how to manage such an amount of information and use it for analysis and decision making. Here we chose to work with Takadu, and today we are monitoring 30% of our network divided in a bit of over 100 DMAs. This has helped us to prioritize our actions and make early detection of network events, preventing these events to become bursts. Our challenge for the future is to monitor our complete network, but the difficulty here are the large investments required to build hundreds of DMAs. But we are studying new alternative technologies that use virtual DMAs, such as bond brain and InfoSand, that should avoid the need of network sectorization. Regarding commercial losses, we all know that they have a strong impact on the non-revenue water levels and representing also an opportunity to increase revenues. Our current situation is that 34% of our meters have overcome their useful life and 96% have low metrological quality. In year 2017, we made a pilot project and replaced 9,000 with smart meters, 9,000 meters with smart meters, and increased the billing by 8%. Last year, we installed 1,200 smart meters in big customers and increased the billing in 5.8%. In conclusion, smart meters have greater precision and other benefits such as better performance with aggressive water and technological opportunities such as remote reading, for example. But the remaining challenge is still to balance the costs of these smart meters and the benefits. Our wish is to have at least all of our meters within their useful life. Now, regarding the network maintenance, we have been focused in root cause analysis and defining smart solutions such as operational changes and network adjustments. For example, intensifying the use of solutions to repair without service interruptions. Through these changes, small changes, we have decreased the clients affected by service interruptions by 60% and the number of breaks by 43% in just a few years. It even helped us to reduce the needs of network replacement. Our goal is to standardize our network operation and maintenance. As I told you before, we have a large company spread in over 100 cities and towns, and this requires high control on performance and on budget. Therefore, we are defining procedures, standards, KPIs, etc., that will be followed in a monthly basis. Finally, regarding risk, we have been focusing our attention on our trunk mains. since they represent a major risk in case of failure. The first challenge here has been to define the way to do the condition assessment at a reasonable cost, starting with the field difficulties since it's an underground infrastructure. There is a wide range of technologies, but the task is, again, to balance cost and reliability to choose the right alternative. Also, as we saw in the last SWAN conference, several providers are promoting the use of artificial intelligence for predictive modeling to prioritize the investments in replacing those main trunk mains. And again, we should have permanent monitoring on these trunk mains to reduce the risk of small leaks eventually becoming big bursts. And again, the challenge is to solve the communication difficulties and battery lifetime of these monitoring systems. We have been working in some pilot projects with Aquarius Spectrum, Pure Technologies, and Aganova, among others, and expect to define how to move on during the next months. As a summary, we could say that first, our main goal should always be the profitability of our actions and not, for example, just a certain level of non-revenue water. Second, not everything needs large investments. Smart actions such as root cause analysis can be very successful. Third, a strong network maintenance plan is key to achieve and sustain the results. Network monitoring is a very useful tool, but it's only a support tool. And finally, the integral network management brings economic benefits such as reducing maintenance costs, production costs, and investments, and will bring sustainable improvements in the service quality and customer satisfaction, which is and will always be our main goal. So thank you very much. And now I'm happy to pass it on to Francisco and Renato from Esval.
Hi everyone. My name is Renato Banzuli. I'm IT manager. I'm with Francisco Itiarraga here in Chile. He's the project manager of operational intelligence. We both represent Esval and Aguas del Valle. And today we will talk about our progress and work methodology that is allowing us to transform our infrastructure in a smart water network. Well, some context about the company. Esval and Aguas del Valle are integrated companies, water utilities that provide services for production, distribution, wastewater collection, and treatment for over 840,000 clients in the 4th and 5th region of Chile. Our investors are Ontario Teacher Pension Plan. They have a long time commitment with Esval and Aguas del Valle. In terms of Chile, when we talk about the service in Chile, we think it's a first-class services because it must include distribution, collection, and also treatment. In particular, Esval and Aguas del Valle have a 99.9 wastewater coverage, a 99.5, and 100 of treatment. The operational complexity in Chile. Well, first, the climate change is also a challenge for us to keep the continuity on the quality of the service. And we have more than 6,000 kilometers of water supply network. So, in addition of that, we have a high magnitude earthquake, sustained droughts, and unexpected rains in high mountains that make the rivers, the turbidity of the river more problematic. In addition, we have a complexity in the network management because of the geographic particularities of both regions. We have a very highly areas with important high difference that requires an optimal pressure warranty to guarantee the continuity of the services. All these challenges drive us to incorporate in our management different proposals with the use of infrastructure and technology tools that contribute to maximize the efficiency and the quality and continuity of the water supply for our customers. One point that is changing our view is that the Esval strategy is focused on customer-centric strategy. Our focus for now on will be to provide a constant added value to the services to our clients and try to exceed the expectations. So today we have absolute clarity that with these new technologies that we are incorporating, if we don't include these technologies, we will not be able to meet those expectations. In the left, you can see that we have the customer satisfaction pyramid. The part that we are focused today is the operational base, that is a relevant one. But we also need to start thinking on how we also incorporate the functional aspect and emotional aspect to the customers. So for us as industry, it's easy to understand how we can use these technologies for optimization, but it's more complicated for us to think in how we can increase client satisfaction at the same time that we are incorporated efficiency in the operation. We are working now to change our culture, to change from being an infrastructure management to a more service provider managers. So in the operational side, what we're using is the 5-layer SWAN model, and the new technologies have brought us new opportunities in recent years because the explosive growth in sensoring at decreasing cost, it's allowing us to have more online data to generate hydraulic variables in the distribution network. So our plan started in 2013 using the SWAN methodology, and this allows us to integrate the necessary activities to move us toward the smart network. During the last 5 years, we have been working in the first 4 layers of the model, and this year we are working deeper in the layer number 5, that is the data fusion and analysis. We have been working in predictive alerts for problems, analysis the online hydraulic models, smart management of pressures, and also a support system for decision making. For us, this layer is the one that it will become or will be the real path for smart water network. We also include an additional slide that is we are using a cyclical model, because after we implement the 5th layer of the model, we can use this information to return to the first layer of the model and start using this for the asset management strategy. So with this operational model, we improve the decision making in maximizing the value of the network, coordinating the balance between what is the cost of renewing the network, the risk, and measure opportunities and benefits based on the information we get from layer 5. Okay, so with this, what we are achieving is we can increase the efficiency of planning of the new infrastructure. We delivering complementary information, so the construction of the new infrastructure meets the design objectives. We also can identify operational strategies for the network, and more important is we can improve the preventive maintenance over the corrective maintenance. So to obtain a highest value on layer 5, we need to evaluate and adapt the existing relationship between people, technology, and process and related with the activities of the model. In terms of the advance or the progress we have been achieving during these last 5 years, on the initial layer, you can see or the physical layer, we have progress in improving the inventory of our infrastructure, improving the definition of the network sectorization. Also, we have optimized our infrastructure maintenance, and mainly in the PRVs. That is a critical element of the geographical, because of the geographical particularity of the zone, with high hills with marked differences in height, and the use of new methods of leaking detection with using lithium. On layer 2 and 3, we have improved the installation of new sensors with GPRS communication, and that has meant for us that now we have online information for 450 controllers and more than 5,000 signals that we are monitoring in both regions, and that is providing us a high quality information in the decision-making process. On layer 3, here we still have a way to go, because as an industry we need to move forward in the definition of an open and standard protocols, but also we need to think in the potential to be integrated with the future development of IoT. In level 4, we can highlight the visualization of strategic indicators in BI platforms, leak detection software using satellites, and the integration of different sensors in a single database. On layer 5, now we are developing different pilots with different technologies for 1 year period each one. And this is implemented in more than half of our network. And for the next year, we expect to have this kind of software in a permanent way to support the operations in the different areas of the company. Okay, so here you can see some of the innovation activities that we have been carrying out during this last year. And we are using it to monitor the smart control of pressures. The continuous monitoring of the pressure in the network for us is the basis to deliver a high quality service. So the data generated allow us to respond quickly to the appearance of pressure problems in the network. Another activity of the smart control of pressure, which has an immediate effectiveness in Esval and Aguas del Valle, is the management of the output pressure of PRVs and pumps. As you can see in the graph, the log losses because of friction in the network was optimized, managing the output pressure of the PRVs based on the flows, and with this the day pressure are improved and the night pressure are reduced, which decrease the probability of burst in the night flows and also prevent the leaks. In this example, we reduce the leakage immediately by 19 liters per second. Other innovation is the use of software that we are testing in layer 5. You can see BandBrain, iNet, and Takadu. This software continuously it's analyzing and fusion data from different sources. And they, as you know, they use advanced mathematical and statistical and hydraulic algorithm, generating continuing learning using machine learning. And we deliver results in real time. The alarms that they generate support the system decision making. And this allows us to go from descriptive analysis, which is now what is happening in the network, and we're moving to a more predictive one, which is allow us to anticipate problems and know what to do beforehand. In this last example, the results delivered by software using predictive models is that they can identify events in a early stage before they become an emergency. One case is a break, which occasionally start as invisible leaks, and they start increasing over the time, and they finally become a big breaks that appears in the surface. In this type of problem, we're identifying with real-time support. It's possible to identify more sooner than later the problems, and we can plan maintenance and repairs and investment before we have a major break. In the graph, you can see the first two ones are small leaks in the network that are increasing over time, and at the end they become breaks. And in these early experiences with predictive models, allow us to understand the need of move from reactive to predictive actions. During the last month, as you can see in the last picture, we have been working in more preventive actions to avoid this leakage. And part of that is change the culture of the company to move from more reactive to a more proactive culture. In that last one, we repaired a leak of 8 liters per second on the second day of that we detect this. Okay, so as results in general, what's the actions to form a smart water network have been implemented. We will have a result of reduction of the level of water losses, and optimization and continuity of the service, and improvement in the regulatory compliance. From 2013 to date, these three indicators have improved steadily, and we have exceeding the initial defined goals. Particularly in 2015, we had an earthquake in the central area of the country, which delayed the evolution of these indicators. But however, anyway, we overcome this emergency, and we are now exceeding the expectation again with this work. So as a conclusion, these new technologies and smart technologies are transforming our utilities industry, and also helping us to get more focus on the client experience. Our integrated network is based on the five-layer model. It's allowing us to coordinate the activities in a sustainable manner, and allowing us to improve the hydraulic performance and reduce the water supply interruptions to ensure a sustainable and more sustainable infrastructure over the time. For us, it's critical to change the culture here inside the company to involve the people in this new way of operation, that more with highest standard involving technology. And all this information that is generated into new smart technologies can made available to the customer to exceed their expectations in the service. So I think that is from our side. Thank you. So now we can hand over Wagner.
Good morning, everyone. First, I'd like to say that it is an honor to be part of this professional international group. My name is Wagner Carvalho, Senior Project Manager at Aegea, and today I'm going to present the Aegea's Smart Water and Sanitation strategy in Brazil. The sanitation in Brazil is a sector with high growth potential. The sewage cover in our country is only 50%, and the required investment is 100 billion US dollar by 2033, according to the Brazilian government agent's plan said. That's why there are countless places out there to recover. Sorry. All right. To recover, and with today's technology and a sustainable approach, there are smart ways to do this. Aegea is a private group of water utilities in Brazil, which began with 6 utilities in 2010, and now we serve 49 municipalities in 11 states, with more than 3.5 thousand employees and over 7 million clients. These numbers represent the 33% of the Brazilian private market share, which is still quite low in total because the government controls 90% of the water sector. All these utilities are spread from the north to the south of Brazil, and there are many challenges to have one model that they can fit in all our concessions. This is the utility life cycle overview from business to operation, which on average have a contract term of 30 years. Below are the main phase divided into 2 groups, which we named virtual, which involves the conception, design, and build the infrastructure, and the other is digital, which consists in operation, maintenance, and decommission phases. All these phases have the hydraulic model in common because Aegea has been succeeding over the years using this tool to create alternatives and new scenarios to support the strategic, tactical, and operational decisions for managing the CapEx and OpEx. This is the smart water architecture developed by the SWAN Forum, and it has been our reference to plan and improve the water system's operation. This basic breakdown of the smart water distribution system represents the water plant, the networks, the pumps, and the customers as a background, and highlight the smart technologies such as intelligent valves, the PRVs, and the transmitters that shares the data with the SCADA, GIS, automatic pressure optimization, and finally the hydraulic modeling, which plays a key role in this system because it integrates the big data and generates an arrival visualization to the decision makers. Investing in cultural transformation is a key issue to achieve our purpose. In other words, our strategy is underpinning in advanced technology investments, customized process, and mainly in people engagement. And in order to improve the workflow, establish an organization culture, and increase the productivity. The expected result is to change the relationship from the informal communication exchange to a collaborative relationship, which all the specialists contribute and look at the same hydraulic model as their one single source of truth. Thus, the Aegea's journey to smart water has got some achievements in advanced hydraulic models and digital twin, as well as facing some challenges with interoperability. We are following some recognized methodologies in order to improve our process, such as BIM PAS 1192 and Asset Management PAS 55, both from the UK, and we are also focused on standardization. And people exchange management approach to achieve the target in compliance, efficiency, and social license to operate. To conclude, client satisfaction is the Aegea main value, and in Brazil, we are working hard in our utilities, reinforcing the safe water value, encouraging the self-regulation, stimulating third-party compliance, and encouraging the customers to keep regular. All these actions in order to have the shared value with our clients. Yeah, thank you everyone, and I will be available to answer any question. Thank you.
Great. Thank you very much, Wagner, and also for Renato and Francisco and Sebastian. So what we would like to do now is just answer some audience questions. We've had some throughout the presentation come in, but if anyone has additional questions, do feel free to put those into the chat box. So for our panelists, I think a good first question just to start with is, how do you go about prioritizing smart water technology adoption and investment? Are these decisions driven internally predominantly or externally driven? Does anyone have thoughts on that question?
Here, Sebastian, I would say that to choose the technology that we are going to use, first of all, there are today a lot of different providers promoting similar technologies. And before we go into one, we study a lot of what they have been doing, the results they have achieved in another utilities. And finally, we make like a small economic evaluation of the solution. And then we go on to a small pilot to test it, to try it, and then make our conclusions. And after that, we decide if we go on with that technology further and bigger, or we choose another one. And I would say that's the way we have been doing it in the last time.
Great. Wagner or Francisco, do you have similar experiences or anything else to comment on that?
Yes, the methodology is very similar for Esval and Aguas del Valle, and as we also looking for new technologies mainly outside of Chile. So one of the reasons we are in SWAN is to know another or new technologies that can be used in US and other parts of the world that we can be incorporated in Chile.
Yeah, from my perspective, I have the same approach. We are looking for technologies that the drivers around the world, and it's been great. And we are experiencing in our concessions with the small concessions, and we develop the technology with our clients, and it's been great to collaborate, to work in this direction, and such as we are working with SWAN and learning and having these case studies as a reference for our implementation in Brazil.
Perfect. Thank you. And I think just to build on that a little bit, talking about the different experiences and projects and case studies that we've been talking about, and then also blending that into a little bit of what you talked about, Wagner, in terms of transformation of culture and organizational culture. Could you each talk a little bit whether the culture of your utility has changed during these endeavors?
Oh, yeah, of course, yeah. Yeah, we consider the main challenge right now is social engagement, yeah, in sanitation purpose. Yeah, and that's my last slide. Show that the clients need to know, develop, and comprehend about the sanitation benefits for all citizens. And for that, we do believe that we can work in a collaborative way with smart water initiatives worldwide to accelerate the disruptive technology adoption, and thus improving our efficiency and of course the main our aim is to offer better services for our customers. Yeah, and with technology they can realize and they get more involved, such as digital twin. And they will understand how our industry works. That's the main point that we are working hard in this direction, the cultural transformation. That's it.
Thank you. Sebastian or Francisco, any thoughts on the culture of utility and how that has changed?
Yes, here in Esval, this started a few years ago with the new general manager. He's absolutely convinced that the utilities must change to be a customer-centric companies. All the time we are being compared with telecommunication company or more service-oriented companies. So he's convinced on that. And since this year, we are been working with an external company to do a change management through all the company based on this new focus on the client. And of course, this need to come from the high management to the rest of the company, and that is something that we are starting this year to involve everyone in this new change.
Well, I would say we haven't made this change so far, or I don't feel we have succeed there yet. Our biggest challenge in the last few years has been to get the operational teams to join the plan. This is a key factor of success, and not only to execute the plan, but to be part of the planning from the very beginning. The big change we need to do is to engage the operational and the maintenance teams, to engage them on the project and have the same goals.
Thank you. And this one is put towards Esval. Could you talk a little bit about any impacts on rates and fees towards customers as a result in the technology investment? And also, what about the savings when it comes to OPEX and operational expenditures for the systems?
Okay, in terms of fee and rates, unfortunately, these investments are not recognized in the rates because we, as you know, we are regulated. So we have been working with the authorities to make them realize the importance of this investment to be considering the rates, because it will bring benefits to the customers. But so far, this is not being considered in the rates. These investments.
Okay. Sebastian, here's a question for you. Looking beyond the likelihood of failure, as you're looking into your assets and systems, do you evaluate consequences of failure for asset renewal decisions?
Yes. What we have been doing to address all our investments in the renewal of the infrastructure is exactly that. We are mapping all our breaks in the networks, and we have been prioritizing the renewals. That is a very large investment. Every year, trying to avoid the breaks and trying to affect as few as possible, as few clients as possible. Our main goal in the last years has been that to avoid to try to impact as few clients as possible for the shortest times as possible. I think our main challenge today is to do that also in the trunk mains. We have been trying to, as I told you before, we have been trying to define a good methodology to make the condition assessment, and then to address the investments, trying to avoid these big impacts of the breaks in main trunks.
Okay. And so hydraulic modeling has been shown throughout these presentations as a key tool in each of your digital journeys and transformations. Could the panel talk a little bit around what the applied software is that was used? And then also, is hydraulic modeling used in a forecasting or predictive mode?
Okay, Kat. It's great question from Alejandro Ernesto. Yeah, we in Aegea we use we apply the blend softwares, water jams and sewer jams solutions that that are supporting us a lot. It's a sophisticated platform, and that can predict, that can help us with the alternative scenarios for the future, long-term vision during the development of our water and sewage master plan, but as well for the short-term decisions, better operation decisions, such as understand how in which place it's more suitable for us, which place and place we can put the smart water valves, the PRVs, and split our in DMAs to improve the efficiency of the water network, improve the pressure management. But our main challenge from this perspective is to have a real-time integrated information using this hydraulic modeling to the real-time decision, and it's helping. We are getting good result in one of our concessions. and we are spreading this idea. But we need to have the reliable information from the field. That's the key question. Involve, as Sebastian said before, involve the sewer and water guy from the field, and collaborate with the hydraulic model, and we are such as Val and Esbio, we are training our team, our specialists, our engineers team in to use this tool, the water gems and sewer gems a lot, and it can integrate all the SCADA, and we are integrating all the data and information to have better decisions. Yeah.
In our case, in Esbio, I would say that for the last 7 years or 6 years, we have been using the hydraulic models a lot. We are using WaterCAD and the pipeline for the modeling, and we have for the last year we have been using SewerCAD for the sewer network. I think it's very important to use these tools. We use them to define all kind of solutions for mainly low pressure problems and also high pressure problems, but as well not only as large investment solutions, but also to find out operational solutions such as sectorization changes, interconnections, etc. So far, we haven't used it for predictive modeling, but I'm sure we will do it in the short time. Since, as I told you, in the last 2 years, we have been working a lot to improve the hydraulic models.
Okay, so here in Esval, from the last well, in Chile, in Esval, we have the hydraulic model for 100 of our network. So from 5 months ago, we started using BuntBrain, that is a Spanish software. That is, we use that software to optimize our hydraulic models. And this software is taking the information from WaterCAD and also from sensors, and it's allowing us to locate the failures in the network. So it's been working fine so far, and this is one of the pilots we are working with for the next 6 months to evaluate and realize the benefits.
Thank you. Okay, I know we're kind of coming close to time. I think we can do one more question, and this is one for the panel as well, and in particular the Chilean utilities. There's a lot of discussion around distribution management. Are there any thoughts or plans being explored around source water availability that's being impacted by climate change? How does technology and innovation fit into this strategy? So this could be Sebastian, Francisco. Any thoughts there around what's happening with your utilities in Chile?
I didn't quite understand the question. Can you repeat, please?
Sure. Are there plans being explored around source water availability as a result of impacts by climate change? And how does technology fit into that?
I'm sorry, you said sewers, water. I didn't get that.
Sorry. Okay. So, for example, 40% of Chile will see reduced water availability by 2045, I believe is a statistic. Are you thinking about how smart water solutions can help deal with challenges regarding source water availability in the future?
Okay, of course. I think technology is a key factor to solve that problem. First of all, we have to reduce the high level of non-revenue water that we have. We have still cities that have 30, 40, or even 50% of non-revenue water levels. and we have to reduce that, and that will be not achievable and not sustainable without the use of all these technologies to locate the leaks, to repair the leaks, and to monitor the behavior of the network, the performance of the network, the night flows, and the pressures, and so on. So it's very important to use these technologies to be able to reach that performance of the network, to be able to confront this problem of water scarcity.
And in Esval, our main focus on related with this is to reduce the leakage. So that will be one source to reduce the required of source of water, and also we will start exploring some software or some initiative to be able to predict demand. So in that way, we can be more efficient in the production of water based on that demand. We're thinking on evaluate solution that can predict demand based on climate factors, on the weather or other variables, so we can be more precise on how much we produce and reduce the leakage together.
Wonderful, thank you. So I think at this time, I know we didn't have the chance to address every question that was submitted. Since we're running to the end of time, what I'll do is I will collect the different questions and submit those over to our panelists and email back the individuals that submitted them. So I do really appreciate each question that was submitted. As always, this webinar will be available later on in the archive, so do look out for that. And additionally, if anyone has questions about the Alliance or webinars in general, do feel free to reach out to me. My email address is Seth, seth.cutler, cutler, @frost.com. So at this point, I'd like to wrap up and really thank again our panelists. So Sebastian, Francisco, Renato, Wagner, thank you very much for your time and insights into the current situation, what you've been working on in Latin America, and also how you're thinking about the future and how we can use smart water and digital solutions to advance really our standing in the industry. So thank you very much for everyone logging in today. And as I mentioned, we'll be getting those questions answered and sent back to you over the next week or so. Thank you very much.